In this example, we want to solve the rational inequality r of x is greater than or equal to 0. When we're given that r of x is equal to x divided by x minus 3 times x plus 2. So what is this saying? This is really just asking, where is r of x, where is our function positive or equal to 0? That's what this greater than or equal to means. So we know that a graph, a rational function, will be equal to 0 at its x-intercepts. And we know that it changes between positive and negative anywhere that, or could potentially change between positive and negative anywhere that we have a vertical asymptote or we have an x-intercept. So what we need to do is try and find our vertical asymptotes and the x-intercepts. And then we'll plot those points on a number line and test intervals on that number line to test whether those intervals are going to be positive or negative. So first, how do we get x-intercepts? Well, we get x-intercepts by setting this equal to 0. So when we set this equal to 0, we know that really all we have to look at is where is the numerator 0. Because if the numerator is 0, the whole thing will be 0. So we just take the numerator and we set it equal to 0. That's our x-intercept, x equals 0. Vertical asymptotes happen at domain restrictions. So we have domain restrictions at negative x minus 3 and at x plus 2 if those are equal to 0. So we get from this that x cannot equal positive 3 and that x cannot equal negative 2. If x is 3, that makes this 0. If x is negative 2, that makes this 0. And we can't have 0 in our denominator. So these are the three values that we're going to put on our number line and give us the intervals that we need to test. So let's draw our number line. So we have a line, number line here. And we need to test, so we have negative 2 here. We have 0 here, and we have 3 here. So we want to test values to the left of negative 2, in between negative 2 and 0, in between 0 and 3, and to the right of 3. So let's pick a value to the left of negative 2, maybe negative 3. So what is f of negative 3? So if I take negative 3 and not f, this is r. What is r of negative 3? So if I take negative 3 and I plug it into my function, what do I get? So it's negative 3 divided by negative 3 minus 3 times negative 3 plus 2. That's going to be negative 3 divided by, that's negative 6 times negative 1, which gives me negative 3 over positive 6, which is negative 1/2. So to the left of negative 2, our graph is negative. We know we have vertical asymptotes here, right? So a vertical asymptote at negative 2, and then we have a 0 at 0, and a vertical asymptote at 3. So let's test the values in between our vertical asymptote and our 0. So let's pick negative 1. What is r of negative 1? If I plug negative 1 in, I get negative 1 divided by negative 1 minus 3 times negative 1 plus 2. In my numerator, it stays negative 1. Negative 1 minus 3, that's negative 4. And then this is going to be positive 1. So negative 4 times 1 is negative 4. So negative 1 over negative 4 is positive 1/4. So we're going to get a positive value in between negative 2 and 0. Let's try a value in between 0 and 3, maybe just positive 1. So what is r of 1? So we have 1 divided by 1 minus 3 times 1 plus 2, which is 1 divided by negative 2 times 3. That's going to give me negative 1/6. So that means this is negative here on that interval. And then pick a value to the right of 3. To the right of 3, maybe 4. So what is r of 4? So plugging 4 in, we get 4 divided by 4 minus 3. Sorry, that's terrible looking. 4 minus 3 times 4 plus 2. So that's 4 divided by 1 times 6, which is positive 2/3. So that's positive there. So we want to know where is our graph positive and where is it 0. So if you recall, we have a vertical asymptote at -2. We have a 0 at x equals 0. And then we're going to have another vertical asymptote here at 3. So on this interval in between this vertical asymptote and this x-intercept, it's positive. But we know that at a vertical asymptote, we can never actually reach that value. So we have to use parentheses there. And then at 0, again, we're looking for where is it greater than or equal to 0. We are going to be allowed to equal that, so we use a bracket. And then it's everything in between there. So the solution for that part is going to be from -2 to 0 with parentheses at -2 and a bracket at 0. And then we also know that this interval is positive. Now, the left-hand side of this interval is a vertical asymptote, so we're going to have to use parentheses there. And then the right side is actually going on forever, so it goes all the way off to infinity, like this. So this is going from 3 to infinity, so that goes from 3 to infinity. And again, we use parentheses for both of these because we can never actually reach infinity. And the 3 we use a parentheses because it comes from a vertical asymptote. So what does this look like in interval notation? Or that's interval notation. In set notation. So it's the set of all x such that x is in between -2 and 0. So -2 is less than x is less than or equal to 0 because of the bracket here. Or x is greater than 3. So this is our interval notation, and then that is our set notation.